Okay, so this is on how we find the inverse of a 3 by 3 matrix. We've looked at 2 by 2 matrices. 3 by 3 matrices are quite hard to find the inverse of, so we'll go through a few things first. And the first thing you need to know is how to find the transpose of a matrix. So the transpose of a matrix is basically found by interchanging the rows and columns. So we swap them around. You'll need to be able to do this to find it. So if, for example, I had a matrix A, which was 1, 4, 2, 3, then the transpose I call A with a superscript of T, and that would be 1, 2, 4, 3. I've swapped the rows and columns. Now, finding the inverse of a 3 by 3 matrix usually takes 5 steps. So there are 5 steps in finding this inverse matrix. So step number 1 is to find the determinant of let's say we're going to find the inverse of matrix A, so we call that det A, the determinant of A. Step 2, we want to form a matrix or the matrix of minors. We talked about minors a couple of lessons ago. We'll do an example going through this in a bit, and we call this matrix M, capital M, unless there's something in the question. If the matrix in the question is called M, obviously you wouldn't call this one M, you'd give this a different letter, but generally we call this one M. And then part 3, from this matrix M, what we do is we form the matrix of cofactors, and we normally call that matrix C, and we do that by changing the signs of some elements or all the elements. It depends. Signs of the elements using the rule of alternating signs. And that means that the matrix goes positive, negative, positive, negative, positive, negative, positive, negative, positive. Okay, 2 more steps. So step number 4, write down the transpose of C, which we're going to call CT, which was this matrix of the cofactors, by changing these signs. And then the last step is that the inverse of A to the minus 1, is found using the formula 1 over the determinant of A multiplied by this matrix of cofactors.